Q.1 A. What is the role of Python in data science? Answer. Python is a popular language for data science because it has a large and active community of users, a wealth of libraries for data analysis and machine learning, and strong support for visualizing and reporting results. Python is often used as a general-purpose programming language, but it is particularly well-suited for data science tasks because it is easy to use, expressive, and has a large and active ecosystem of libraries and tools. Many data scientists use Python as their primary programming language, and it is a common choice for implementing machine learning models, data wrangling and visualization, and other tasks in the data science workflow. B. Differentiate list and tuple in Python. Answer. In Python, a list is an ordered collection of objects that can be of any data type, including other lists. Lists are defined using square brackets and can be modified after they are created. For example, hash define a list. My_list is equal to 1, 2, 3, 4. Hash modify an element in the list. My_list 1 is equal to 5. Hash add an element to the list. My_list.append 6. A tuple is also an ordered collection of objects, but it is immutable, meaning that the elements of a tuple cannot be modified once it is created. Tuples are defined using parentheses and, like lists, can contain elements of any data type. For example, hash define a tuple. My_tuple is equal to 1, 2, 3, 4. Hash cannot modify an element in the tuple. My_tuple 1 is equal to 5 hash. This will raise a type error. Hash cannot add an element to the tuple. My_tuple.append 5 hash. This will raise an attribute error. One key difference between lists and tuples is that lists are mutable and tuples are immutable. This means that lists can be modified after they are created, but tuples cannot. This can be an important consideration when choosing which data structure to use in a given situation. For example, you might choose to use a tuple when you want to ensure that the data it contains cannot be modified by mistake. C. Explain data science pipeline in details. Answer. A data science pipeline is a series of steps that data scientists go through to solve a data-related problem. These steps can be broadly grouped into 3 categories. Data collection and preparation. This includes tasks such as gathering and cleaning data, and selecting a subset of the data to work with. Data exploration and visualization. This includes tasks such as exploring the data to better understand its properties and relationships, and using visualizations to help communicate findings. Model building and evaluation. This includes tasks such as selecting and training machine learning models, evaluating the performance of different models, and fine-tuning the chosen model to improve its performance. The specific steps and tools used in each stage of the pipeline will depend on the problem being addressed and the data being used. Some common tools and techniques used in data science pipelines include programming languages like Python and R, libraries for data manipulation and analysis like NumPy and Pandas, and machine learning libraries like scikit-learn and TensorFlow. Q.2 A. What is HTML parsing? Answer. HTML parsing refers to the process of extracting data from an HTML document. HTML, Hypertext Markup Language, is a standard markup language for creating web pages, and it consists of a set of tags and attributes that define the structure and content of a web page. Parsing HTML involves analyzing the HTML document and extracting the data that you are interested in. There are several ways to parse HTML, including using a library or framework specifically designed for the task, or using a general-purpose programming language like Python. Some popular libraries and frameworks for HTML parsing include Beautiful Soup, LXML, and HTML5lib. These libraries provide functions and methods for parsing HTML documents and extracting data from them in a variety of formats, such as a tree-like structure, as a dictionary, or as a list of tags. HTML parsing is often used in web scraping, which is the process of extracting data from websites in order to automate tasks or gather data for analysis. It is also used in web development, to extract and process data from user input forms, and in other applications where data needs to be extracted from an HTML document. B. Write a Python code to find factorial of number using function. Answer. Here is a Python function that calculates the factorial of a given number. Definite factorial, n. Calculate the factorial of a given number. Parameters. Dash 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 dash. N, int. The number to calculate the factorial of. Returns. Dash 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 dash. Int. The factorial of n. If n is equal to 0. Return 1. Else. Return n asterisk factorial, n1. To use this function, you can call it and pass in the number you want to calculate the factorial of as an argument. For example, factorial 5 hash returns 120. Factorial 10 hash returns 36288800. See, explain dictionary in Python with example. Answer. In Python, a dictionary is a collection of key-value pairs. It is an unordered, mutable data type that is used to store and retrieve data efficiently. Dictionaries are defined using curly braces and are made up of keys and values separated by a colon. Here is an example of a dictionary in Python. Hash define a dictionary. Person is equal to name, John Smith, age, 30, city, New York. Hash acts as an element in the dictionary. Print, person, name, hash output, John Smith. Hash add an element to the dictionary. Person, country, is equal to United States. Hash modify an element in the dictionary. Person, age, is equal to 31. Hash remove an element from the dictionary. Dale person, city. In this example, the keys of the dictionary are name, age, city, and country, and the values are John Smith, 30, New York, and United States, respectively. Dictionaries are useful for storing data that needs to be quickly retrieved using a unique identifier, known as a key. Note that the keys in a dictionary must be unique and are typically strings, numbers, or tuples. The values can be of any data type and do not need to be unique. Dictionaries also do not have a fixed order, so the elements may be returned in a different order than they were added. Or C. Is string a mutable data type? Also explain the string operations length, indexing and slicing in detail with an appropriate example. Answer. In Python, a string is an immutable data type, which means that once a string is created, it cannot be modified. This is in contrast to data types like lists, which are mutable and can be modified after they are created. Here are some examples of common string operations in Python. Length. To get the length of a string, you can use the lay function. This function returns the number of characters in the string, including spaces and special characters. For example, S is equal to hello, world. Length 13. Indexing. To access a specific character in a string, you can use indexing. In Python, strings are indexed starting at 0, so the first character in the string has an index of 0, the second character has an index of 1, and so on. To access a character at a specific index, you can use square brackets and specify the index of the character you want to access. For example, S is equal to hello, world. S, 0, hash access the first character. H. S, 5, hash access the sixth character. Comma. Slicing. To get a substring, or slice, of a string, you can use slicing. Slicing allows you to extract a portion of a string by specifying a start and an index. The slice will include all characters from the start index up to but not including the end index. You can also specify a step value to skip characters in the slice. For example, S is equal to hello, world. S, 05, hash get the slice from index 0 to index 5, not including index 5. Hello. S, 6 happy smiley hash get the slice from index 6 to the end of the string. World. S, 2, hash get every other character in the string. Hello, WRD. Q.3, A, list and explain any three magic function. Answer. In Python, magic functions are special methods that have double underscores at the beginning and end of their names, also known as dunder methods. These methods are used to define behavior for certain operations in Python, and they are called automatically when the operation is performed. Here are three examples of magic functions in Python. _init underscore. This magic function is used to define the initialization behavior of a class. It is called when an instance of the class is created, and it can be used to set up the instance variables and perform any other necessary tasks. Class myClass. Definite underscore init underscore self kiss smiley. Self.x is equal to x. Hash create an instance of myClass. Obj is equal to myClass 5. Underscore. This magic function is used to define the behavior of the built-in lay function when it is called on an object of the class. It should return the length of the object. Class myClass. Definite underscore init underscore self items. Self.items is equal to items. Definite underscore self. Return lay self.items. Hash create an instance of myClass. Obj is equal to myClass 1, 2, 3, 4, 5. Hash get the length of the object. Lay obj hash output 5. Str. This magic function is used to define the behavior of the built-in str function when it is called on an object of the class. It should return a string representation of the object. Class myClass. Definite underscore init underscore self name. Self.name is equal to name. Definite underscore str underscore self. Return self.name. Hash create an instance of myClass. Obj is equal to myClass John. Hash get the string representation of the object. Str, obj, hash output, John. These are just a few examples of magic functions in Python. There are many others that you can use to define the behavior of different operations in your code. B. Explain slicing rows and columns with example. Answer. Slicing is a powerful feature in Python that allows you to extract a subset of a sequence, such as a list, tuple, or string. In the context of rows and columns, slicing can be used to select a subset of rows or columns from a data structure, such as a data frame or matrix. Here is an example of how to slice rows and columns in Python using a list of lists, a matrix. Hash define a matrix. Matrix is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Hash select the second row, index 1. Row is equal to matrix, 1. Print, row, hash output, 4, 5, 6. Hash select the second column, index 1. Column is equal to, row, 1, for row in matrix. Print, column, hash output, 2, 5, 8. Hash select a submatrix with rows 1 and 2, indices 0 and 1, and columns 1 and 2, indices 0 and 1. Sub underscore matrix is equal to, row, 0, row, 1, for row in matrix, 2. Print, sub underscore matrix, hash output, 1, 2, 4, 5. In this example, the matrix is a list of lists, where each in a list represents a row of the matrix. The first slice matrix, 1, selects the second row of the matrix, and the second slice, row 1, for row in matrix, uses a list comprehension to select the second column of the matrix. The third slice, row 0, row 1, for row in matrix, 2, uses a list comprehension to select a submatrix with the first 2 rows and the first 2 columns. Slicing can also be used to select rows and columns from a data frame in Python. To do this, you can use the .illoc or .loc attributes of the data frame, which allow you to select rows and columns using integer-based or label-based indexing, respectively. For example, import pandas as PD. Hash create a data frame. df is equal to pd.dataframe, a, 1, 2, 3, b, 4, 5, 6, c, 7, 8, 9. Hash select the second row, index 1. Row is equal to df.illoc, 1. Print, row, hash output, a2. Hash b5. Hash c8. Hash select the second column, index 1. Column is equal to df.illoc, 1. Print, column, hash output, 1, 4. Hash 2, 5. Hash 3, 6. Hash select a subframe with rows 1 and 2, indices 0 and 1, and columns A and B. Sub underscore df is equal to df.illoc, 2, 2. Print, sub underscore df, hash output, AB. Hash 0, 1, 4. Hash 1 to 5. See, what do you mean by missing values? Explain the different ways to handle the missing value with example. Answer. Missing values, also known as null or NA values, refer to data that is missing or null in a dataset. They can occur for a variety of reasons, such as when a value is not available or not recorded, or when a value is encoded as a placeholder like NA or null. There are several ways to handle missing values in a dataset, depending on the context and the nature of the data. Here are a few common approaches. Drop rows or columns with missing values. This approach involves simply removing rows or columns that contain missing values. This can be useful if the missing values are few and there is no way to impute them, or if the missing values are not representative of the rest of the data. Q.4a. Explain hist function with code. Answer. The hist function in pandas is used to generate histograms. A histogram is a graphical representation of the distribution of a dataset, which shows the frequency or number of observations within different ranges or bins. Here is an example of how to use the hist function in pandas. Import pandas as PD. Import matplotlib.py plot as plt. Load a dataset. df is equal to pd.read_csv, data.csv. Select a column to plot. Kernel is equal to df, kernel1. Plot the histogram. Kernel.hist. Show the plot. plt.show. This will generate a histogram for the values in the kernel1 column of the data frame. By default, the hist function uses 10 bins, but you can specify a different number of bins using the bins parameter. You can also customize the appearance of the histogram by using various optional parameters, such as range, density, hist type, color, etc. For example, kernel.hist, bins is equal to 20, range is equal to 0, 100, density is equal to true, hist type is equal to step, color is equal to red. This will create a histogram with 20 bins ranging from 0 to 100, with the density of the data shown on the y-axis rather than the count, using a line graph style, and with the bars colored red. B. Write a program using NumPy to count number of C element y's in a given array. Answer. Here is an example of how you can use NumPy to count the number of C elements in a given array. Import NumPy as NP. Create an array. Ar is equal to np.array, a, b, c, c, a, c. Count the number of C elements. Num_c is equal to, ar is equal to c, dot sum. Print, number of C elements, num_c. Output. Number of C elements, 3. In this example, we first create an array using the np.array function. Then, we use a comparison operator to create a Boolean array where the elements are true if they are equal to C and false otherwise. Finally, we use the sum function to count the number of true values in the Boolean array, which gives us the total number of C elements in the original array. C. What do you understand by data visualization? Discuss some Python's data visualization techniques. Answer. Data visualization is the process of creating visual representations of data, such as graphs, plots, and charts, to better understand and communicate the insights and patterns in the data. Data visualization can help to identify trends, patterns, and correlations in the data, and can make it easier to understand and communicate the data to others. There are many different techniques and tools for data visualization in Python. Some popular ones include Matplotlib. This is a low-level library for creating static, animated, and interactive visualizations in Python. It provides a wide range of options for customizing the appearance and behavior of the plots, and can be used to create a variety of different types of plots, including line plots, scatter plots, bar plots, and histograms. Seaborn. This is a higher-level library built on top of Matplotlib that provides a more intuitive interface for creating statistical graphics. It is particularly useful for exploring and visualizing statistical relationships in datasets. Plotly. This is a library for creating interactive, web-based plots and visualizations. It provides a wide range of options for customizing the appearance and behavior of the plots, and can be used to create a variety of different types of plots, including line plots, scatter plots, bar plots, and heat maps. Bokeh. This is another library for creating interactive, web-based plots and visualizations. It is particularly well suited for creating visualizations for large datasets and can be used to create a variety of different types of plots, including line plots, scatter plots, bar plots, and maps. Alter. This is a library for creating statistical visualizations in Python, based on the Vagelite visualization grammar. It is particularly well suited for creating simple, concise visualizations and is designed to be easy to use and learn. These are just a few examples of the many data visualization tools and techniques available in Python. Ultimately, the choice of which tool to use will depend on your specific needs and the type of data you are working with. Or Q.4. A. Explain bar function with code. Answer. The bar function in matplotlib is used to create bar charts. A bar chart is a graphical representation of data where the length of the bars represents the magnitude of the data. Here is an example of how to use the bar function in matplotlib. This will create a bar chart with 3 bars, one for each category, and the height of each bar representing the corresponding value in Y. You can customize the appearance of the bar chart by using various optional parameters such as color, edge color, width, align, etc. 4. Q.5. A. What is scikit-learn? Answer. Scikit-learn, also known as sklearn, is a free and open-source library for machine learning in Python. It provides a wide range of tools for tasks such as classification, regression, clustering, dimensionality reduction, model selection, and preprocessing. Scikit-learn is built on top of NumPy and a CIPy, and integrates well with the rest of the scientific Python ecosystem, such as matplotlib for plotting and pandas for data manipulation. It is designed to be easy to use and efficient, and is widely used in both academia and industry. Some of the key features of scikit-learn include: point a consistent interface to a wide range of machine learning models. Point simple and efficient tools for data mining and data analysis. Point access to a wide range of datasets for testing and experimentation. Point robust and performance-tuned implementations of many popular machine learning algorithms. Overall, scikit-learn is a powerful and widely used library for machine learning in Python. It is well documented and has an active community of users and contributors. B. Explain box plot with example. Answer. A box plot, also known as a box and whisker plot, is a graphical representation of a dataset that shows the distribution of the data and identifies any outliers. It consists of a box with horizontal lines, called whiskers, extending from either end, and a line, called the median, dividing the box into 2 halves. Here is an example of how to create a box plot in matplotlib. Import matplotlib.py plot as plt. Hash data to plot. Data is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hash create the box plot. plt.boxplot, data. Hash show the plot. plt.show. This will create a box plot for the data in the data array. The box represents the interquartile range, IQR, which is the range between the first and third quartiles, 25% and 75% of the data. The whiskers extend from the box to the minimum and maximum values, and the median is shown as a line within the box. You can customize the appearance of the box plot by using various optional parameters, such as whiskers, caps, medians, etc. For example, plt.boxplot, data, whiskers is equal to 5, 95, caps. C. Write a Python programming to create a pie chart with the title of the popularity of programming languages. Sample data. Programming languages: Java, Python, PHP, JavaScript, C#. C++. Popularity: 22.2, 17.6, 8.8, 8, 7.7, 6.7. Answer. Here is a Python program that creates a pie chart with the title of the popularity of programming languages, using the sample data provided. This will create a pie chart showing the relative popularity of each programming language, with the percentage of total popularity shown next to each slice. You can customize the appearance of the pie chart by using various optional parameters, such as colors, explode, start angle, etc. For example, plt.py, sizes, labels is equal to labels, autopt is equal to %1.1f%, colors is equal to red, orange, yellow, green, blue, purple, explode is equal to 0, 0.1, 0, 0, 0, 0, start angle is equal to 90. This will create a pie chart with the slices colored red, orange, yellow, etc., with the Python slice exploded slightly, and with the chart starting at an angle of 90 degrees. Or Q.5. A. Define covariance and correlation. Answer. Covariance is a measure of the relationship between two variables. It indicates how the variables are related to each other and whether they change together. If the variables tend to increase or decrease together, the covariance is positive. If one variable increases while the other decreases, the covariance is negative. If there is no relationship between the variables, the covariance is zero. Correlation is a normalized measure of the relationship between two variables. It ranges from -1 to 1, where -1 indicates a strong negative relationship, 0 indicates no relationship, and 1 indicates a strong positive relationship. Both covariance and correlation can be used to quantify the strength and direction of the relationship between two variables. However, correlation is easier to interpret because it is standardized and has a fixed range, whereas covariance can vary widely depending on the scale of the variables. B. Explain scatterplots with example. Answer. A scatterplot is a graphical representation of a dataset that shows the relationship between two variables. It consists of a set of points, each representing a pair of values from the two variables, plotted on a Cartesian coordinate system. Scatterplots are useful for visualizing the relationship between two continuous variables and identifying any patterns or trends in the data.